whenever you want. And if you have questions or you want to comment something in chat, please use it as well. So I assume that if it's question, I will answer. If it's comment, I mean, you can just interact as if you were sitting in one room. So that is our digital way of doing stuff. My name is Alexey Pasichny. I'm now a research engineer at KTH Royal Institute of Technology. Hopefully start a postdoc in a month. And very shortly, where I come from. So I was born in Mariupol. I was very much enjoying the quality of energy systems in my city when I was small. So that was a picture that I had from my window. That probably was a reason why I, at the end, ended up in the working with energy for cities. And I did my applied mathematics and systems analysis degrees in Kiev Polytechnic Institute in Kiev. And then I started to work more with sustainability issues, so working with education and a bit of research there. And that's how I got to work with Olga and Victor Kordas. And after a while, moved to Stockholm, where I worked with strategic planning for heating sector for a while. And this was both on the qualitative and quantitative sides. And I wanted to do a PhD more on the quantitative side. So that's how I ended up doing my PhD in urban energy data analysis, focusing particularly on building issues. And I finished it just a few months ago, defended in December. Here our group is called Urban Analytics and Transitions, and we basically focus on two aspects: analytical part and participatory part. This is used for running changes in city scales. So for those of you who have not come earlier, I ask everybody to fill in this Menti. So I will maybe just copy a link to the chat. So for those of you who would miss this slide, you could still use it. And as I understood, your main project, Erasmus one, is about Industry 4.0. And before agreeing to Victor to make a talk on this project, I had a very brief, fast overview of, for me, what Industry 4.0 concept is. And normally, if we had a bit more time, I would just talk to you in the room. But I hope this picture didn't deceive me and gave me a bit of a right understanding of what is expected under this umbrella term. And I would focus today mainly on the data, a bit of touching simulation security, and and maybe that's it. As I explained, it would be mainly connected to energy and cities because that is my background. But I will try to connect it also to this concept that I saw in this picture. So if we talk about the data, in cities, so clearly there is a huge change about situation if I compare like 10 years ago, even and now. So what is changing? So one thing, we have really very good connectivity. So we have 5G already rolled out, and we have lots of technologies for local different grids and meshes, and that brought a kind of concept not of only Internet of Things, but Internet of Everything. And of course, it's driven by lots of redundancy in means of computational power and means of data storage. We have also moving computational processes towards the end process. So what is called cloud computer and edge computer. So if we have cloud, it's basically about how we redistribute computational power in a more efficient way. And if you talk about edge computing, it's about how we bring the computation as close to the end client. So basically, if you have a mobile phone, how to do calculation as close to your application on your mobile phone. And then, of course, lots of data streams, and they become in real time and very detailed. And also lots of application development in means of methods for analysis and software libraries and application frameworks. So all of this makes things much more potentially integrated and usable. And big data is basically another umbrella concept that stands behind all these developments. So I like very much these 4 or many V's. Sometimes you can find up to 7 V's of big data. But I like these 4, the main ones. So in means of changes, you could say that clearly we have exponentially growing volume of data. So we have much more data created in the last 2 years than in previous humanity life. And then it's variety. So if we compare like 10 years or 20 years ago, and now there is much more of this unstructured data when you have lots of images, videos, just texts, so verbalic information. And then it's velocity, and this means also in means of how fast the data is changing, but also it means of that it's real time. So it's mean that more and more systems have either very small or no delay, like it's negligible delay if we think of 4, 5G networks. And then it's veracity, and that is one of the main problems that actually with more and more data, it doesn't mean that we have better situation, because sometimes we just have more and more of problems to solve and less certainty in what we are looking at when we see this data. And to compare with, I like very much concept small data, and if to be very like precise, I would say that I'm working more with small data than with big data. So, and in many, I think in many areas, it's still kind of mainstream, but we can clearly see that a shift is happening. So basically, it's not that we work with small data because big data is not available, but it means that the methods and the capacities, and these are very often, I mean, not technological ones, but human ones, are not really developed for working with big data. So we kind of have not solved, and we have not developed all issues for the small data perspective to be ready to intake big data very often. So, and this leads us also to this broader definition of big data, that is very often the data that the traditional instruments are not capable to work with. So sometimes even small data can be big for the domain where it was not typical. So if I take my example of building energy modelers, so the modus operandi like 5 years ago when we were starting was for them to work in Excel. So if they want to do some analysis for the city, they work with Excel. And at that time, Excel was even limited to the, not RAM, but some, I think there was some physical constraint for a while on amount of table. So if I would load, for example, all energy declarations, which is around 1 million buildings for Sweden in Excel, I mean, before it could not even load. Now it can be loaded, but there is no sense of it because it would be not usable really. It would be so slow that no questions can be asked. So yeah, you could see these different ways how they compare to. So structure, like real time, all these things distinguish big data. And of course, volumes. We are talking about really large volumes. And in this regard, big data is not about the data only, but about the ecosystem. So it's about the instrumentation, about databases, about sensors, about the networks, and also the softwares, about how we reduce this dimensionality and how can we extract anything useful from it. But then also business processes about which applications are developed and how it's integrated into the conventional decision-making workflows. So in this regards, it's a really huge ecosystem. So it's just to give you an idea of how many different directions it can take. So so I'm working only with R and Tableau in this. So it's just two small pictures here, and maybe several more could be added, like Mapbox and yeah, some databases that we have. So that is big data. And then we have another, I think, if you think of Industry 4.0 for cities, then of course it's about openness of data. So because it very often, if you think how the like technological process of the city is developed, it's about having transparency and also trustworthiness of made decisions. And also it's very often about public-private collaborations. So it means of, if you compare like open and closed data, so open is something like that everybody has access to. So the traditional example from old times is bus timetable. You come to the bus stop and you can see the timetable, and that is open data to everybody. And then you have very, very closed data, something like, for example, contracts made with the users of electricity network, or your subscriptions to the medical like system. So this is very personal, private information. This is closed information. But then there are information in between, and that is kind of a bit challenging. Also, how you make this public-private data lake. So, from my example, if I take the meterings from energy utility, then it's usually for them it's very closed information. But then we want to generate some knowledge to guide strategies for Stockholm City, and then it obviously becomes more like group-based access or public access. So we need to agree on which aggregation and anonymization procedures we should take to make move from this closed to shared levels. And this is can be a very powerful tool. So it's associated with a very good economic effect. So because you can run lots of innovations if you open up data in cities. And you could also have third-party development of private products. So, for example, our first ride planning app in the city was developed by a private person, just based on the open data. And of course, it's also adds up a lot to the interoperability of different actors. So if you think of, for example, energy efficiency company coming in and renovating building, so they could benefit a lot if this data like available from the national actors like Energy Efficiency Agency or National Board of Housing could be shared to them. So that is why we discuss that data should be open. But on the other take, open data means that you are very much exposed, and cities don't like it really, because as soon as you publish something, then somebody would say, okay, look, they are not efficient here. Or people would start questions, okay, why you have these strange numbers reported? So it doesn't go very fast as well, because this means lots of change in everyday like routines. And also it can be pretty resource consuming. So in this regards, it's a question like, do you have this extra financing to do this opening up data? And this is a very famous guy. I believe you should have known about him. So it's Tim Berners-Lee, the creator of World Wide Web. And one of his main recent efforts in last decade was connected to the development of the concept linked open data. So there is 5-star ranking to make it very easy. So it starts with just publishing whatever you have on the web, and then improving the quality of what you publish. So you make it more structured. For example, you could also add some metadata information about it, what you publish. You could make usage of open formats, not Excel, but CSV, for example. And then you could also start linking things. So you could point to these objects. So you make a constant identifier that it could be used to share it across world. And then the fifth one is basically to add a semantic meaning behind this data. So if you describe it in a proper object models, then you can tell machines what is this they are looking in and make them automatically take it if it's applicable. So this is how it looks in the picture. So you can see from PDFs to linked open data. And in case of cities, we have very complex situation. So we have lots of different industrial and societal systems interconnected, and information flows all between those. So you could see we have upper layer of nature, so different environmental systems, and then urban infrastructures, and it could be water, energy, waste, mobility. And then we have, of course, different areas of like city services associated with this. So we could have ecosystem services, we could have education services, administration, and so on. And then it's all can be accessible via different platforms on different levels. So it could be both on the physical groupings, like house, buildings, neighborhoods, districts, cities. But it could be also on the societal structures, like it would be different organizations, communities, and so on. So if we think of where data comes from, there are four rough main categories. So it's transactional data, that is most traditional one that was initially stored in databases. Like if you take your mobility card, like if you go and take the subway, so you leave the transaction, or if you go and pay for coffee, that is a transaction. So anything that can be recorded as a record in the database is a transaction, more or less. And then you have sensors, and this could be in place in situ, or it could be remote. And of course, we have a huge rollout thanks to Internet of Things of smart meters and different infrared cameras and so on. But we can have also remote observations, like starting from remote sensing from space, but also local surveillance in some crowded places, for example. And then the most unstructured thing is citizen-generated data. And this could be from very simple, like the smileys in Arlanda airport, but it could be also tweets, Facebook, different photos on Instagram, and so on. So if connect this to the different areas that I mentioned before, you could have lots of different phenomena observed on city scale. And just to give a very brief example of how it could look in different forms from different sources, I will rush through different examples. So that is air quality in my native city. It's photographic information. So if you take photos from the same place every day, probably we could extract from here the information about how clean is the air in Mariupol today. And the same thing, the same phenomena could be studied in a more structured way if we connect different sensor networks into this air quality sensor network, and then we could aggregate this sensor meterings into some aggregate index, like you can see here, the air quality in Beijing, not far from Mariupol. And then citizen-generated data. This is example of OpenStreetMap. This is a project that is fully created by the people tracing the tracks and then correcting them manually. So that is the historical development of OpenStreetMap. So how people were adding up streets in London, and then you could see it on a larger scale, the coverage of OpenStreetMap throughout years. So that is a pretty fascinating example of crowdsourcing. I think only Wikipedia probably is even larger and more impressive. So lots of information could be added by people, so they should not be disregarded. And very often it's only people who can verify the data. So what, for example, Google Maps do when they ask you, do you know this place? They verify the data that was collected previously. And then this is an example of, I think this tool actually was taken down. I would not be able to show now, but it was demonstrating. We had for a while opened up the tracking of the public transport in the city. So you could see almost real time. It was a bit updated, like with some lag, maybe 15 seconds each, how buses, subways, trams ride around the city. So almost real time. And you could have, for example, services like they have pretty in every American city called 311. So everybody heard about 911, right? It's emergency services in the US. But 311 is when you have not so much emergency, but you have some anger on city and you want to put it on your mayor or somebody related. So that is how you basically can improve your city a lot. So you could have access to many of these data sets in an open way. So in New York, you can download like 10 years of 311 service request and see what are those types, in which places they were happening, how they were recorded, was it phone or email or online. So, and what was the measure? Like, was there any reaction, or was it left unresolved, and so on? So that is also citizen-generated data. And then this is an example when you leave Stockholm and go to the airport, you pass these cameras. And that is this system for paid enter to the city. So whenever you come to the city, you need to pay. And it's done automatically. So the system reads in the car plate and then recognizes the registration number, and then it automatically bills you for entering the city. So that is an example of connecting remote sensor and transaction data. And one more, so that is a mapping of geographical coordinates of pictures uploaded to Flickr. So Flickr is not so popular anymore, but historically there were pretty lot of pictures made. So, and this is basically intensity of mapping. So you could see where tourists mostly go to in Stockholm, just from looking at coordinates of the pictures uploaded to the service. And that is example of actually modeled data, but based on some registers. So it's kind of not big data at all, but that is what we try to redevelop based on more use of smart meters these days. So here you could see the energy performance of the buildings, even not buildings, but blocks in New York. So this is pretty old map. I think it's now 8 years old, but it played its important role guiding many people around the world on what to do next. So to summarize, we have lots of instrumentation, lots of interconnectivity of systems, and it's making things very complex. It demands lots of much more advanced models. But it also gives us lots of new opportunities. So we can make more operational reaction of the cities. We can also do much more sophisticated strategic planning. So we can develop different advanced models and see what would happen if. And yeah, and make cities also pretty more responsive. So in a way more adaptable to the current needs. So, and one of the way to do it, what is pretty actively developing now, it's city dashboards. So when you try to make it all as a in the car, but on some virtual screen where you have everything regarding one topic in place. So that is what I summarize by under the concept of urban analytics. So it's data, methods to work with data, tools that are involved in these methods, and actors. So I think it's really important to add up this non-technological part here. So what are stakeholders of your systems? Because otherwise it can be pretty about everything and not having any focus. So it's whenever you develop your like data-based methods and tools, it's very important to think about the end user. And it could be very much different depending on whom you talk to. So I start coming with more cases now. Any questions so far? Because you're very silent, and I hope it's. Let me know if any appears. So in case of Stockholm, we have a strategic target of the city to become fossil-free 2040. And for this, lots of buildings should be improved. So it's associated that buildings should become at least more than 30% more energy efficient. And at least 30% reduction should be achieved yeah, for the existing buildings. And this leads us into this quest for energy efficiency, and we have lots of different actors. And the problem is that they have very different targets. So if you think of energy utilities, they want to be clean, like in a public image, but of course they want also to do it in a most cost-efficient way. So they want like basically flat energy production, ideally as much as possible. And yeah, so that is, so they want to the people and buildings to keep consuming energy. And then we have building owners and managers. They have almost opposite problem. So they want to consume as less as possible, but at the same time they have the same targets to reduce their costs. So they are cost-driven still. We have energy solution companies that don't really care about the emission targets, and but they want to make a business on reducing energy consumption of buildings. So they can have the first one and make things harder for these energy utilities. We have people that don't want to pay a lot. Probably they don't care pretty often about emissions unless they're very environmental aware. But they also care about their thermal comfort. So basically, sometimes for them, it's even can be a balance between cost and quality. So they can actually agree to pay more if they get a better quality of life in their residences. And then we have cities that have political targets. So they do want to reduce emissions. And then, of course, they still want to do it in a cost-efficient way, so they don't spend all their city budgets on it. And then we have state authorities that usually have political targets, but also they want people to be happy, so they re-elect them once again. And in case of Stockholm, we have 2 projects now running. So these are all my supervisors from my PhD. And this is pretty interdisciplinary team here. So we have energy modeler, economics guy, also working in energy utility as R&D. We have Olga, who is good in mathematics and writing papers. And we had Hussein, who is good in talking to people and making them agree to give us all their data, even though we don't promise much from the beginning. And these are types of actors we work with. So these are city, energy service company, energy utility, association of building owners, and association of oh no, so this is association of building owners, and this is association of housing associations, basically housing associations. And then these are funders, and for the second project, we have one more city, software company, energy utility, and a larger umbrella company for these housing associations. So I would not go much into the project, but talk about some of these project aspects. So one thing that we try to develop is kind of develop this public-private data lake. So we take in different data sets from different sources. So we have metering data about use of energy all around Stockholm. So all buildings that connected to the district heating network. We have energy declarations. So these are buildings from data from the building audits collected by the National Board of Housing. We have cadastral data collected by the Geocadastral Agency of Sweden. And then we have also 3D models from the city. Yeah, good luck. Thank you. We have climate data, and all this is integrated, aggregated into one place. So we have our own data warehouse, which we work in on the research side. So we have more generalistic tools like R or Python, and we have more dedicated tools for building energy simulations that are not very much adjusted for the batch simulations. So there is an issue how we can do it in a batch mode. And then we have different outer interfaces for these partners from society. So we have still very traditional Excel or PowerPoint reports. We have more interactive dashboards developed in Tableau. We have some online tool developed, and we have also target to come to more automatic program interfaces, so that city departments or energy utility departments or housing association could take some data that we calculate automatically just through the link. And in case of where data comes from, it's a really nice example of the infrastructure for heating that we have in Stockholm. I think it's very much aligned into this Industry 4.0 concept. So it's a fourth generation of district heating. So you could see that there was a purely technological aspect of development for district heating networks. So we had change of fuels, decrease of temperatures due to the efficiency of the networks. And then you had more of these cogeneration plants in the second generation. And then you added up renewables, so geothermal energy and some heat storages. But then you could see that already from 3G, third generation, we have data centers appearing here. And then we start to do this more smart way of controlling the network. So it's two-way network in fourth generation. So we can have heating and cooling, and we can have some synergies between different clients in the network. So network starts to be not very much top-down, but more like a brokerage infrastructure. So, and it's really huge. So if you think of geography, it's something like 100 kilometers from Södertälje here in south to Arlanda in the north. And it has like these blue ones, I think, are the largest burners, but then you have some smaller ones. So different colors are for different partnering utilities, because here you could see roughly 10 different municipalities connected by this district heating network. And it's all integrated, but there are also some segments of the network that are more autonomous, so they kind of have smaller interchanges. And I would like to just bring a few examples of where this IoT and smart control can be in use. So one example is a project called Stockholm Data Parks. So what they do, they invite for developing a dedicated data centers that are from the beginning by design very much interconnected into the this district heating and cooling network. And you use this network to basically to cool down the data center, And the heat that you extract from the data center is then passed to the residential consumers. So in this regards, you have win-win. So you provide cooling to those who need cooling, and you provide heating to those who need heating. And of course, the question is of how can we optimize the building energy performance? So in this regards, energy utilities they are very much disturbed about, okay, would not energy efficiency harm their business? And in this regards, we also try to understand, okay, if we do some measures, what would be the effect? Would it be neutral? Would it be negative? Or could it be also positive effect? So this is a tool that I developed just to make a discussion of opening up the data publicly. So it's an interactive map, like the one that was developed for New York, but based on already on the really metered per building data. And now what Exergy does, they developed this service called IntelliG. So they install inside houses indoor temperature sensors. And they develop a new business that is provided for the housing association. So how can you optimize your building energy solutions to improve indoor climate? So now they connect the data that was coming from the metering stations with these indoor climate sensors. And in this regard, they know about the buildings much more than we researchers in KTH or city knows. And this is proprietary data that we don't have access to. But we have access to meterings, which still is very helpful. And what we try to do on our side is basically to develop the simulation engine and the decision support tools that would look like this at the end, that would allow to click on any building on this map and see its benchmark, how it performs across the similar buildings, and what would be the possible measures that could be done, and what are the expected outcomes of these measures. So for this, we need really advanced models. So before we were modeling sample buildings, so building of one type, and just trying to understand how we can scale out these measures results. So what we do now is we try to take all this data that was integrated and feed it into the dedicated simulation engine, run the simulations, and then get results. And for this, you need much more simulation. So just to calibrate the model and make it run as close to the real building, you can probably need up to 500 simulations. And if you want then to test different solutions, that would be maybe another like 50 simulations. So we need lots of computational power and to do it in a very intelligible way, how you can do it so it still makes sense. But then we are very much inspired on how it becomes also more and more practical to be used in the city. So this is a tool that we are working just last month. So Stockholm is now reviewing their requirements to the developers. So whenever they agree to develop a new area, so as city owns the land, it can set up requirements. Okay, the building that you're going to build on this land, they are going to meet this energy performance criteria or this quality of materials in means of environment. So we do different sample simulations. I can try to show it how it looks in a live way. Yeah, so we still kind of merge two effects, two approaches. So we have sample buildings that are run still in different number of combinations. So, and we, for example, enrich this with the real measurements. So we have hot water consumption for like 200 apartments, and then we use this profile to simulate 40 apartments in new building. And then we have cold water time series that we also use and forecast how the temperature will change across the year. And then we have different versions of this one building and second building. And we can have different assumptions about the CO2 intensity of the grids, both for district heating and for electricity. And then we can calculate also the political factors, because they also play with the primary energy factors. So, for example, we started with one, but then they introduced penalty factor for electricity, and then now they even give more to district heating. So it becomes really much different if you compare the both energy and primary energy, and that is basically what is a politically used indicator to guide the development now. So, and with different models, you could see different outcomes, like what would be the overall energy performance. So this is the process that informs city what are the targets that should be made. So is it realistic or not? And like, what are the outcomes, for example, of buildings switching from district heating to ground source heat pumps? So what would be the change in the energy performance and carbon intensity? So that was about heating. And if we connect to electricity, this is, I would say, even more in mass. So if we talk about smart grids, I'm not working much with this, but I will give just very few examples. So one thing that you have lots of decentralization happening. So you lose this top-down structure, and you have much more this both directional operations in the grids. You have more active consumers that can install their own production units, becoming prosumers. And you have also lots of intermittency in the grid. So now you have lots of renewables that is fluctuating much more than, for example, nuclear reactors or hydroelectricity. So you need really a smart algorithm to coordinate all this complexity. And this could be actually used also for very low-tech society. So it's what I'm talking is not only about rich and developed countries. So even this example with heating data was about how you make smart dumb buildings. So we are looking a lot with these old buildings that were constructed 100 years ago and trying to understand how they look like just from looking from the metering data. But this is an example in Brazil, the energy company Enel, they introduced waste sorting for electricity bills program. So you have these poor districts like favelas, and they very often they don't have really leave like money cash to pay for the electricity. But what they could do instead, they could collect the waste in the streets and bring it, sort it, and then they can get directly to their billing system in the electricity extra credits. So in this regard, they promote this improving the quality of life in these poor communities, and also provide them more access to the electricity and accordingly basic needs. And another example, it's a project run by the Fortum in India. So they do collaboration for the battery swapping. So you know that there are lots of these small mobility like rickshaws in India. And then, of course, even though they are not very large, but usually they are very old and dirty. And now the Indian government, they try to promote as much as possible to switch those to electrical cars, like let's call them cars, I don't know how, motor-rollers. So they, what they propose is that because of course they don't want to wait. So, and one of the counter argument why not to switch is that you need wait for charging. So what they do instead, they propose very fast battery swapping. So when you have small terminals where you could come and just pay for you leave the old battery that is uncharged and take the new one. And in this regards, you make it even faster than full engine with petrol. But it could be also very advanced on level of buildings. So if you think of grids, it's for consumers can be seen through this home energy management system, where you could see the price of electricity, you could see the consumption of your energy, and also set up different patterns on if you want to do it in a more sustainable way, or if you have urgent wash up of your clothes, or so on. So lots of nice things promised, right? And let's talk a bit about the dark side of the data.
And it's possible to ask a question before switch to dark side.
Yeah.
Let's stay on the bright side.
Bright side, yeah.
My question refers to your slide where you had this energy efficiency versus generations of these approaches from 1 to like. So where the energy efficiency reaches, it looks like it reaches a plateau. But energy saving.
You mean these models for buildings, or
no? Before you had before you switched to examples, you had a general presentation of energy saving.
I will go early.
Yeah.
You tell me.
Here you just no. It's later. Yeah, or this one.
This one.
No. Before this. This one. So it looks like energy efficiency is about to reach kind of plateau, and normally it also means that expenditures for reaching this efficiency, they are also usually getting higher because all the low-hanging fruits are already taken.
Yeah.
And, so how about this, whether you have some solutions for like go or no go with this energy saving, because it can cost more than the cost of energy itself, the savings you achieve.
Yeah, so one thing, of course, when you talk about the investments, like you should understand that now in Stockholm, it's very often not energy efficiency that drives the investment. So it's very often the carbon emissions that drives the investment. So in this regards, we have still interest in going in a more advanced solutions just because they probably allow to use the same amount of energy, but in a more cleaner way, right? So that is one comment. But another is it's clearly about synergies. So this example of this heating and cooling, I think this is where you have lots of rise of energy efficiency, because what we had before we had separately heating of residences, and we had separately the cooling of data centers, and accordingly all this energy was wasted because it was consumed separately. So I would say that integration is, I think it's seen one of the main like drivers, enablers of this higher hanging fruit of energy efficiency.
Yeah, okay. And it's not always more expensive. So like
no, I mean if you think of Kyiv, for example, 10 years ago, Olga was going there with Swedish businesses working with large industrial heat pumps, and there was a consideration for the project that could be financed by this NEFCA, I think it's called Nordic Energy Efficiency Collaboration, that could basically take so in Kharkov district, there are 3 objects close to nearby. So we have waste incineration plant Energia, you have Bortnichi aeration station, and then you have cogeneration heat power plant of the tech nowadays, not before it was Kyivenergo. And the idea was that you could take the waste heat from the sewage at Bortnichi, then warm it up with the waste in Energia, and then only in peak times you would need really to heat it up further at the cogeneration power plant, because basically you would get most of energy just from waste heat and from waste residuals. But they didn't run. But of course, the self-occupancy, payback period was something, I think, like 7 years or 5 years. So it was.
It's not bad.
Yeah, it was not. It was huge. I mean, we are talking about basically 1/5 of energy need of Kyiv. So I would say that this integration of systems has been a really huge potential. And in this regards, the disconnection of the grids, like what happens very often in Ukraine nowadays, like when you have shut down of the heating networks, of course, it's in long run, it road to nowhere. I mean, they would come back at some point to this. But it would need, of course, lots of extra investments then. And another example, I didn't put the slide here, but I can open, I can just tell. So the problem, for example, is also in capacity of electric grids nowadays. When you introduce lots of renewables and you have lots of electrification. So if you think of even heating in cities, lots of consumers switch to electricity-driven sources like heat pumps or direct radiators or boilers. And then this means a huge shock for the system. So in Stockholm, there is nowadays around 300 megawatt shortage of internal municipal grid capacity. So they had to agree with Exergy that they would use their cogeneration to guarantee production of power, not of heat, even though it's prohibited by the monopolization unbundling law. But they had kind of to reverse it, and it was very disputable because Exergy didn't agree to it until they were promised a good price, so they got a really good margin. So they got a fixed contract for 50 years until 2007 that they are allowed to sell 300 megawatts of electricity extra on market conditions, not on the fixed tariff. So in this regards, I think coming back to the energy efficiency question, there is clearly a place for improvement. And yeah, I would bring one more picture. I now know what would be the good illustration for here. Just give me 1 sec. So if I talk about the energy efficiency, I think lots of improvement lies on the side of non-technological ones. So technologies are there. So the question is, just a second, it starts up. It lies really on side of laws, regulations, agreements, and so on. So yeah, here it is. So if I go to my other presentation, so this is Hammarby Sjöstad. I know you were there, right? So there are two buildings here. I'm zooming in very close to here. Built in 1 year, opposite each other. The same function, residential buildings. The difference in energy efficiency is twice. One is consuming something like 130 kilowatt hours per square meter. Another is something like 65, 70. And the only difference was basically that this green building, they made a competition open up. So the developer that proposed better project was selected. Here it was prefixed developer. So the one that got the lot by just initial agreement with the city. And they basically didn't care about what they are building in means of energy performance. So this is an example when just making the this agreement on the targets and setting up these publicly transparent competitions could make much more difference than invention of new heat pump or installation of photovoltaics. It was nothing, I mean, technologically it was a heat recovery ventilation that they added, but it was no photovoltaics, no like super smart technologies.
The cost was comparable.
It was just a more tight envelope, and yeah, so yeah, maybe it was 10-20% of cost more, but in long run, of course, for city, I think if we think that this building would probably exist for 100 years, it's much more profitable to build this kind of buildings, and they pay much more attention, and this is why now we develop this tool, because that is basically about how you set up requirements to these new buildings.
Thank you.
Good.
Let's go to the
dark side of the moon, right? Yes. Give me a sec. And the dark side of the moon, actually, we'll start with an example from Ukraine.
Почали надходити дзвінки з різних частин області від наших енергодиспетчерів районів. Це було несподіванкою, так як ці частини між собою енергетично не з'єднані. Це щось відбулося незвичайне. Коли ми подивилися на наші комп'ютери, то побачили, що курсори мишок самі рухаються, хаотично рухаються по різних підстанціях, і вони вимикають вимикачі, вимикають лінії, трансформатори. Що робити? Отримали підтвердження, що є зовнішнє втручання, і в телефонному режимі дали команди диспетчерам, щоб вони на місці направили бригади, звичайних електромонтерів на ті підстанції, щоб повторно увімкнути лінію. Того дня було знеструмлено десь 200 тисяч населення нашої області.
So, this is example from Ukraine, which is actually very popular for our cybersecurity professors in KTH. And yeah, so the question is that as long as we have more and more automation with these very complex technological systems, of course, there is a question of how isn't it vulnerable for some other intents? So can it be used to make extra profits or just bring down half of the country from the light or so on? So I think if you think of large blackouts for energy grids, I would say that the noticeable share is related basically nowadays to the algorithm, either to the hacker attacks, or it could be also like wrong trading algorithms when algorithms create kind of coupling of loads, and that brings this blackout to small segments of grid and then large ones. So security is one problem, but then another one is privacy, and there is lots of different types of privacy. So we can think of protecting personal and confidential data, right? Medical records or main income records. But it could be also bodily privacy, like what Tesla does to your body when it drives you. It could be territorial privacy, like if your house is still yours, and location and movement privacy. So of course, if we have minute resolution on the hot water consumption on the apartment level, we can understand if the family moved out for vacations or not, like roughly speaking. We think about communication privacy. So, and this could be on the level of really not emails, but also about these messages that are sent by the network coordinating company to the smaller producers. So you could use it for good, like for predictive maintenance of your wind turbine, but you could also do it for bad, like to go bring them into the mode that would basically break them down. And transaction privacy. Yeah. So it's pretty much what I was talking about. And you could have different solutions to this. So I would not stop much of this because we have not much time left, but roughly just the main idea is to start thinking about it before you have the end product rolled out. So that is the main concept, because very often people that develop these systems, they don't take it seriously. They think, okay, it's just a nice experiment for us as researchers or us as developers. Let's make it for fun to show it's possible, but then at the end it can hit pretty hard the end user. And also thinking of the urban solutions and this public good related stuff. Of course, we also have this question of would it be used for public good, because you could develop very nice systems, but do they really help society or private interests? That is another question. And that's why we need to think about the ownership and control, who owns the data and who controls these software systems. We should think about the integration and data markets. So it's about, okay, the data that was produced by consumers is now owned by the company. So can we open it up through proper data exchange marketplace? Or do we have right standards, or they keep it in the proprietary format that would probably make it impossible to others to use it? And then data security and integrity. And that is not only about the breaches, it can be also about just better quality data. So we can have really data that like it's not covering up all the system, and in this way it's not usable. Data violence and privacy, we talked about it a bit. Quality, provenance, and usage. So usage can be very different from what was by design. And this example of this heating company, I like it very much in regard that they never thought of themselves in the beginning as when they wrote out the smart meters as a data business. But now we can see more and more that it becomes a part of their basically operations, and they try to make profits on this. So in this regards, data usage has changed from what was initial intent. And to inspire you for other, like provoke you for other conversations, I would like to show you one last movie here. And that is, oh, no, that I already showed, sorry. And that is about the Chinese social credit score. So when we come to Smart City Expo every other year before Corona started to Barcelona, it's very interesting to see what are different perspectives on smart cities from different parts of the world. So how American companies sell it, what Arabic countries think smart cities are, and also India, China have very different visions. So probably you've heard about this social credit system from China before. You can Google about it more, but I would show just a very short video fragment.
In some of China's largest cities, a high-tech effort is underway to bust low-level offenders, jaywalkers. Cameras record them going through intersections, zero in on their face, and then publicly shame them on nearby video screens. It's all part of the Chinese government's new social credit system, where people's daily behavior is monitored and rated. I think it's a good thing, this woman said. It makes people more honest. But this social credit rating goes far beyond a traditional credit score, which is based on your finances. China's version factors in everything from jaywalking to smoking on trains to buying too many video games. If your score gets too low, you can be banned from buying plane tickets, renting a house, or getting a loan. Nearly 15 million people have already been prevented from traveling. Journalist Leo Hu is one of them. He recently tried to book a flight but was told he couldn't because he was on the list of untrustworthy people. I can't buy property. My child can't go to private school, he says. You feel like you're being controlled by the list all the time.
It can recognize more than 4,000 vehicles.
Chinese technology firms such as SenseTime are helping the government effort by developing advanced cameras that use artificial intelligence to track just about everything.
This knows every person, every bike, every car, every bus that goes through the frame.
You can tell whether it is an adult, a child, a male or female.
Police in Beijing have been wearing these glasses that can recognize faces linked to the government's national database to help boost arrests.
How advanced is this technology?
This is cutting edge.
Wu Fei is CEO of a company that makes the glasses. He claims he doesn't know how the government intends to use his technology.
I have no idea.
Really?
Yes.
Do you trust the government the way they're using your technology?
Sorry, I can't answer this.
You can't answer that.
This is outside our scope of questions.
The fear, of course, is that the government may use this social credit scoring system to punish people that it deems not sufficiently loyal to the Communist Party. And trying to clear your name or fight your score is nearly impossible because there is no real due process. Jeff?
So what do you think? Would you like to have such system in your city?
Well, I think my opinion is technology can develop very rapidly. Like human attitudes, it's needs more time. And in order to bring these two processes in line, probably Chinese government put this system in place because too many cars, but people behave as if all of them are still bicycles. And in this way, probably they can, make people more rapidly change their mindset towards the demands of Industry 4.0. Actually, as someone who is, I believe, is doing no wrong, no harm, I would actually like this system be in place for some time, and then to check what will be the effect.
Okay, thank you. Any more opinions on this?
I see there are only Ukrainian participants now and some words on Ukrainian. Я дуже дякую вам за цю презентацію. Вона була дуже інформативною і така ілюстрованою. І я бачу, що ця презентація майже цілком може бути використана для наших студентів, незалежно від тої спеціалізації, на якої вони навчаються. Будь то перші слайди, які стосуються взагалі парадигми 4.0, будь то ті, які стосуються безпосередньо applications, big data and so on. Тому дуже дякую вам, і я вважаю, що може будуть якісь продовження цієї презентації, які мають такий прикладний характер. Це саме для викладання дисциплін з цього напрямку, з цієї парадигми, це є дуже інформативно, як на мій погляд. Дякую вам.
А як щодо цієї системи в Покровську? Social Credit Score.
Треба подивитися.
Доки в мене насправді є ще один слайд, тому якщо можна, я закінчу, але дякую вам за... Якщо по кредитній системі ми закінчили, я закінчу, да? Добре, тоді ми вже договоримо. Останнє, що хотів показати, що це цікава такий сервіс від MIT Moral Machine. І це гарна демонстрація щодо, якщо про social credit це питання того, хто задає правила, да? Тобто це все одно люди, фактично наприкінці, і питання, яка мета цих людей, тобто що їм рухає, і чи не можуть бути до вас якісь персональні претензії, що будуть використовувати цю систему просто для того, щоб не дати пану Володимиру відвідати місто Стокгольм більше не разу. Чи це дійсно буде за те, що він там когось образив на зупинці? Є питання до того, як ці системи використовуються, але ми розуміємо, що це більше social systems problem. А от якщо ми кажемо про socio-technological issues, то це от moral machine. Тобто, яка демонструється проблема? Тобто, у нас є машина, яка драйвиться штучним інтелектом, і фактично це опитування, яке ви можете пройти, і воно вам пропонує там серію ситуацій, коли ви маєте вирішувати замість штучного інтелекту, що зробити в тій чи іншій ситуації. Ну, і як ви бачите, жодних гарних виходів там не буває, тобто там або так, або сяк, якийсь вибір вам треба робити. Ну і насправді дуже часто у нас є ця multi-criteria decision making, коли немає ідеального рішення, тобто у нас все одно є якась оптимальність, коли ми маємо знайти якийсь компроміс. І насправді відношення до людей до рішень, які зроблені машинами, воно трошки відрізняється, ніж до тих самих рішень, зроблених людьми. І це насправді причина, наприклад, чому в Копенгагені повністю роботизована система метро їздить досі з водіями. Не тому, що водії там щось роблять, а тому, що люди мають іншу довіру до системи, коли в вагоні метро є кабіна, і в кабіні є хтось схожий на живу людину. І от насправді це чіпає декілька проблем. Тобто, з одного боку, етики цих рішень, а з іншого боку, ще агентності людей. Тому що, якщо ми кажемо про цю всю автоматизацію, наприклад, розумні будинки, тобто будинок сам визначає, яка вам підходить температура, чи варто вам відкрити, от у нас тут штори, вони закриваються тут, коли сонце, незалежно від того, хочу я чи не хочу. І в цьому плані мене, як мешканця цього будинку, мене лишають цієї агентності. І от питання в тому те, що коли ми маємо ці більш роботизовані міста, тобто наскільки, що ми залишаємо людям і, фактично, де ця межа. От на цьому, мабуть, все. І, тобто, я дуже дякую вам за увагу. Я готовий до продовження подальшої дискусії. Якщо у вас були якісь питання, дякую.
Дякуємо. Дуже дякую. Було дуже цікаво. Цікаві приклади. А взагалі, що стосується машин, то я чув, що виробник